Yay! Are you even or are you odd? That is today's question. Who feels even today? Who feels odd? Anyone feel neither? Oh, I don't know. It doesn't really mean anything at all. It's just my being silly and you feel tired. Okay, if you feel tired, then maybe you feel neither. Some feel even. Yeah, so what we are doing today is we are looking at various functions, not just rational functions, not just polynomials, a wide variety of functions. And we're learning about two special types of symmetry that don't always occur. And that is every function is either even, odd, or neither. Now, you're being told here that this first graph is an even function. And what you want to notice about it, I'm going to draw you a line. And I'm going to say, take a good look at that even function. And now, here's another function that is stated to be even, and I'm going to draw that line again. Even functions are symmetric over the y-axis. I repeat, even functions are symmetric over the y-axis. Now, when something is symmetric over the y-axis, if you pick a positive number for x, let's pick 1, and then you take the opposite of that number, -1. If I am symmetric over the y-axis, the same y value is going to come out from +1 as the number that comes out from -1. These have to be the same number. That's what it means to be symmetric over the y-axis. Let's take a look, though, at the equations. And x squared is just a nice, easy one. If I put in 1 or -1, do you see that I square it, I get +1? Same. That isn't what I wanted to do. Same number. These are the same. And I can take anything, 2 and -2. They're both going to come out as 4 for their y value. Same y value. Over here, if I look at the equation and I look at +1 versus -1, and actually, do you notice something interesting about the exponents? What are both of those exponents? They're both even, divisible by 2. They're both even numbers. Is that a coincidence with the fact that they call this an even function? It is not coincidence. This is where the names are coming from. Even exponents say whether you're positive or negative, I don't care, you're all coming out the same. So whether I put in +1 or -1, I am getting 1 minus 5 times 1, so I'm getting -4 for both of those y values. And you can see that over here as well. Now, that's what an even function does. Here are odd functions. And do notice that the one odd function given here, that is an odd exponent on a polynomial. This one is not polynomial, but this one is rational. And I ask you a very, very important question. What is the exponent on this denominator x? It is an odd number. We're going to talk about that a little bit more as we go through this classwork. But what would you call this symmetry that occurs with an odd function? It's almost like it does the even function's reflection over the y-axis, but does what after that? Do you guys see? What does it do after that? Flips one of them. Yeah. If you look, actually, I just realized I may not be explaining myself what I'm meaning to explain. When we looked at those even graphs, you saw a reflection over the y-axis. With the odd ones, it's almost a reflection, but what might you, what?
It's a reflection over the coordinates or the specific points.
Yes. Oh my goodness. And what's really funny? They call this origin symmetry. You don't have to worry too much about that phrase, but I'm going to write it down. It is called origin symmetry. But the idea is if you have opposite signed x coordinates, their y coordinates are going to come out opposite signed. So with x cubed, when you put in 1, you get 1. When you put in -1, you get -1. With x cubed, if you put in 2 versus -2, 2 cubed is 8, -2 cubed is -8. So when the x's are opposite signed, the y's are opposite signed. Now that doesn't mean that a positive x gives a negative x. It just means that, because if I looked at the graph of -x cubed instead of x cubed, that would still be an odd function. But -x cubed -x cubed causes the positive 2 to create a -8 and the -2 to create a positive 8. The main thing is if these are opposites, these are opposites. And that's what makes something to be considered an odd function. Now, you might see a graph that has a type of symmetry, but it's not even or odd. Even or odd is a very, very specific type of symmetry. So now we're looking at the class of neither. And that's an issue of, yes, this does have symmetry over the line x equals 4. But does it have the type of symmetry of an even or odd? It does not. So it's neither. Things are either a reflection over the y-axis or a reflection about the origin, or it is neither. Here again, we see that this looks like it's got symmetry about this center point, but that center point isn't the origin. So it doesn't get to fall under the class of even or odd. All right. And then this is just to emphasize what I was saying before of In an even function, you get the same y value. And here, this is, I don't feel like calculating. I'm going to be honest with you. Let's just look at these. So you can see with the even functions, with opposite signed x's, you get the same y. Opposite signed x's, you get the same y. But with odd functions, opposite signed x's give you opposite signed y's. Opposite signed y's. Okay? And so that's basically what you need to notice. And I'll give you a moment to write that down. I can say, juniors and seniors, the good news about your science test is you're just going to present your knowledge and not worry about that going against you if you don't do well enough. You just put out there what you know and be on your way and not even worry about it. That's the one thing that's nice about those state tests is you can relax on that issue and just do what you know how to do. And have I given, it looks like some people are still writing, so I'll give it. Oh, the science test, how long will it take? It's going to vary. I am not entirely sure. I just know it's going to vary from person to person. Most likely people will finish before the time is up. But I don't know for sure because I haven't seen the test. I can't tell you how long it takes. And everyone's different. Okay, I'm going to go forward then and go back over here. And did I already, we just did this for number 4, correct? Or did I not do that? No, didn't. Oh, yes, I remember now what I wanted to have you do. This is important. With an even function, do you remember that with a graph, if you multiply the x by a negative number, it horizontally flips it around the y-axis? If you have an even function, doing that won't affect anything. So multiplying x by a negative number will cause the same thing exactly. If you replace an x with the opposite x, the function can be simplified to its original state. With an odd function, if you take an odd function and you horizontally flip it around the y-axis, that is no different than if you multiply outside the function by a negative and flip it over the x-axis. So you'll get the same result whether you flip over the x-axis or the y-axis. Those will be equal. If you replace an x with a negative x, the function can be simplified to negative 1 multiplied by its original state. Now, determining even, odd, as well as neither with polynomial equations. That needs to be mentioned. If all of the exponents that you see are even, you have an even polynomial. all exponents are even. However, there's something that you need to know. Let's say I have x to the fourth plus x squared. So far, that's an even function. It's symmetric to the y-axis. If I move it up or down, is it still symmetric about the y-axis? If I take a graph and I move it up or down, is it still symmetric about the y-axis? And let's take a look. Let's look at these even graphs. If I take this function and I vertically shift it, let's say I shift it like 2 units up, does it still have y-axis symmetry is what I'm asking. It still has y-axis symmetry. So I want you to know with polynomial functions, if you have a constant added, where did it go? Oh, too far. If you are adding a constant, it is still even. The thing is, with an odd polynomial, it has to have all of its exponents odd, but you cannot have an extra constant added on. Your constant term has to be 0. So you shouldn't see a constant term. So if I have y equals x cubed minus x, that is an odd function. But if I add a number onto that, it is no longer odd. And if you look at the origin symmetry, the graph is going through the origin, or maybe it has a vertical asymptote at that spot. Let me show you. For the graph of 1 over x, you have a vertical asymptote right there on the y-axis itself. The polynomial graph goes through the origin. If I were to vertically shift this, do you see that would lose its symmetry of being odd? So if I vertically shift this up, I no longer have the situation where I can just flip it around the y or the x and it's exactly the same graph. It has to go through the origin or have a vertical asymptote going on there at the origin at 0 to be odd. So odd's got to have some special extra bits. Now, if you have any mixture of even and odd exponents, it's neither. If you have odd exponents and a constant and it's not 0, it's neither. Before I move on to rational equations, I want us to start looking at identifying on our own a few of these. Oh, those are the answers. Oopsies. Ha 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 ha. Okay. All right. So on number 7, letter A, we have a table of values. And what you want to look at on a table of values are the opposite signed x's. So I'm highlighting a pair of opposite signed x's. What do you notice about their y values? Opposite signed x's, what do you notice about their y values? Do you notice that they're the same? That means that this is even. And I want you to notice that I didn't look at x equals 0, because that gives me a y-intercept. But I want to remind you, with an even function, if you vertically shift it, it doesn't affect it being even. It doesn't change that. So for an even function, it doesn't matter what happens at x equals 0. It only matters that opposite signed x's have the same y. All right, now let's look at b, this polynomial here, f of x. I have 3 terms. Term number 1 has an odd exponent. Term number 2, is that an odd or an even exponent? It's understood to be 1, so it is odd. So this looks like it might be an odd function, but it has a constant added on. Is it an odd function? Nope, this one falls under neither. And then next we've got a lovely graph. Does that graph look like it's even, odd, or neither?
Neither.
Let me make sure that you see where the x and the y axes are. This is your y-axis. And this is your x-axis.
Oh, they're reflections of one
Yeah,
another.
yeah. After you said that, I realized that it might not be obvious that those are the 2 axes. And then once you see that, do you see that odd symmetry? And it's just kind of like going, it's like trying to mirror each other. I don't know if you see what I'm doing here, but like trying to opposite mirror. Anyway, stop blinking. All right, let's do another batch. Look at this table, and I want you to decide, is that even, odd, or neither?
I said
So what I'm going to do is I'm going to look at opposite signed x's. For that one pair, the y values are opposite signed. At this point, even is not going to happen. So essentially what you can do is you can go, it's either even, or it's odd, or it's neither. Once you determine that something can't be even or odd, it narrows it down. This is either odd or it's neither. So I want to keep looking. Opposite signed x's, do they also have opposite signed y's? Yes. But I have to check 0. If I know what x is equal to at 0, it must be 0. It has to go through the origin. So what do you think? You were correct. This is odd. Woo! Yeah. Okay. Will you listen to me? No, you won't listen to me. My pen is being rebellious. Yeah. Okay. Next one. You have a nice little equation. Do you think it's even, odd, or neither? Oh, I was supposed to start your quiz. So I'm going to open up your quiz. Everyone's going to take the quiz, but you're going to stay online. I'm also going to keep going and talking about this. Actually, give me a second to think about. I need to pause my video.